What are some things you recall from the past about slope? And we'll raise our hand to share. Okay.
Y equals mx plus b.
Okay, this is everyone's favorite. I'm gonna put this down here in the bottom corner because it's not exactly slope. It has something to do with slope, but it's not slope. What about this equation is the slope? Willie? Let's focus on this one. This is not an equation for slope, but it has slope in it. Where's the slope in it? The m.
Oh, is that the x?
No. The m is a slope in what's called slope-intercept form. We'll talk more about that thing next week. Jack?
Rise over run.
Okay, one way to describe slope is with rise over run. We said that m is the letter we use for slope. Does anyone remember anything else about slope?
Isn't there like a y minus y1 x minus? Oh my gosh,
Absolutely, this would be a formula. Make sure you jot this down. This is an important formula to calculate slope. That would give you 2 points.
I remember that.
Okay. Willie?
this is exactly so, but like b and y equals mx plus b is like the same intercept for the rest of
I'd rather do shapes.
B is the y-intercept, yeah. That's not really so much to do with slope, but it is a part of that slope-intercept formula. Again, we'll spend more time on this thing next week. I don't remember anything else about slope. Another way to represent slope, how you would represent this in, say, your science teacher, Miss Krieger, would write it like this. Hopefully you've seen these symbols before. Has she ever used those symbols in class before? Those little triangles?
No.
Those little triangles are called delta, and I know she has because I've seen them on the board when I go down there for lunch, so don't give me this idea. Okay, yes, she's shown them to you. The little triangles mean change.
I seriously do not remember.
Change, they're the Greek letter delta.
Oh.
And the Greek letter delta, which represents change. And notice change is subtracting the two quantities. So delta x means change in x, so we'll describe change by subtracting. But all of this stuff just kind of is fluff. It talks about slope, but doesn't actually say what slope is. What is slope? What is slope?
Like how steep or the line is.
Okay, on a graph, slope is how steep a line is. Even more general than that, what is slope? What does slope describe? Does anyone remember what slope describes? What is it? We're talking real life. What is slope? With all these numbers, what is slope? Does anyone remember? It's amazing how we can memorize these little formulas, but we don't really know what it actually is telling us. It's kind of a downfall of the American educational system at this point. Slope is a rate of change. Slope describes how fast something changes. It's a speed. It's how quickly y is going up versus how quickly y is going down. It's steepness. On a line, when you look at a line, how steep it is how fast y is changing as x gets bigger. It's how fast your car goes. If you're looking at, in, say, a situation, if you can describe the speed of something, you're describing its rate of change. You're describing the slope of whatever equation you could draw or write for this car moving, or for this person running, or for the stone being thrown, or for whatever. For the price of something. Price per unit. It describes change. Slope is change. Slope describes it. And that's more or less the reason why we spend so much time on slope in 7th and 8th, and now in Algebra 1. because it's change, and life is change. And it models change. It's all about slope. It's all about change. Things that you definitely need to remember from this little brainstorm would be this formula.
Whoa, whoa, whoa. That is funny.
Okay. Those two things are probably the most important. Whereas rise over run is nice. All rise over run is just describes rise, change in y's, run, change in x's. But it's change in y, change in x. Rate of change. Now that you all have written that formula down, so that we can use that formula going forward.
Let's do one.
Let's calculate the slope. Which one of these points is the first point? Which is the second point? Better decide that first, because your slope formula has y2 and x2 and y1 and x1. Which one's the first point and which one's the second point? Jack? Is going to be which one? The first point. Sure. We'll call this the first point. For no other reason than I wrote it first. So recall the slope formula says something like this. y2 minus y1 over x2 minus x1. The little subscripts, the numbers written below, indicate first and second. So if this is the first point, then this is written as x1, y1, first x, first y. And if this is the second point, how are we going to write this? The second x and the second y. Oh look, we've just identified the four things we need to plug into the slope formula. So what this is saying is that y2, the second y, minus the first y, divided by the second x, minus the first x. Negative 1 minus 2 is negative 3. 4 minus 5 is negative 1. And what's negative 3 over negative 1 the same as? Positive 3. Negative divided by negative is a positive. 3 over 1 is just 3. Okay, so the slope as a number is 3. All right. Do I need to go through these 3 examples, or can you spend some time on your? You want to do these on your own?
Do it on our own.
Can we handle these on your own? Okay, I'll do one of the graphing ones, and then you'll have to finish the front side on your own. Yeah, you'll do that one on your own. Graph the lines that go through these points, and then find the slope. Well, if I tell you graph and I tell you 2 points, that life's easy. So let's plot these 2 points. Negative 2, x is left 2, y is down 2. 6, comma 4 goes left, right 6, 1, 2, 3, 4, 5, 6, and up 4. Happens to be at the corners of the graph. And connect them. Calculate the slope of this line. Well, you could use the formula. You have 2 points and you have a nice formula. You could do that. If they're graphed, however, we can use the idea of rate of change, or change in y, or change in x. How does y change? When I start, let's say we start here. How does y change? How far do we go up to get to the next point? Jack?
You rise 6 and then you run 8.
We go rise, so we go up 1, 2, 3, 4, 5, 6. We go up 6. And then we run, or we change in x. We go 2, 3, 4, 5, 6, 7. We go to the right, or plus 8. Slope is change in y over change in x. Or we rose 6, and we ran 8. So the slope is 6 over 8, or this reduces to a nicer fraction, which is what? What's 3/4? Which would be the slope of this is a reduced fraction. Rise over run, change in y's over change in x. Bam. Okay. -2, comma 2, back 2, up 2, right 3, up 1. I'm going to draw a line between those points. Using the graph, you get the slope is I go down 1, and I go to the right 5. So the slope is -1 over 5.
Did you seriously just draw those lines?
Yeah.
Or was that cheating?
No. I'm that good. When I'm focused, I'm that good. You could also, you alternately could have started here and said I'll go up 1 and go left 5, which would be -5. So you get positive 1 over -5, which are the same thing. What's a negative divided by a positive? Negative. Positive divided by negative. Still same thing. It's a negative. Either one. Gives you this. What kind of line is this?
Horizontal.
It's a horizontal line. Okay? What's the slope of this horizontal line?
0.
I go up 0 and over 6. And 0 divided by anything is 0. The slope of a horizontal line is always 0. Okay? Compare that to this line. -3, comma 1. -3, comma -3. What kind of line is this? It's a vertical line. What's the slope of this vertical line? The slope of this vertical line, if the slope formula would be how much do we change going from here to here? I go down 4. And how much do you change in the right and left direction? 0. So the slope we would want to write is -4 over 0. This needs to ring some bells and say this is bad. We can't divide by 0. This is called undefined. A vertical line, the slope is undefined. If you have an undefined slope, you divide it by 0, then you know that your line has to be vertical. It has to be straight up and down. Okay. All right, let's look at some actual usage of this. This table shows the cost to paint a house by the given hour. Find the rate of change in cost with respect to time. How much does the cost of painting change with every bit of time? I'm going to find the rate of change. What is rate of change? Slope. So let's find the slope. Let's find the slope or the cost per hour, or the change in cost over the change in time. Find the rate of change in cost with respect to time. Something with respect to time would be with respect to anything else divided by. So pick 2 points on here, and let's find how they change. How about we look at the first one and the second one. And let's use our rate of change formula, our slope formula. How much does the cost change from 1 to 2? How much does it change to go from 90 to 135? How are you going to figure that out? Subtract the 2. 135 minus 90 is $45. How does time change? Since we started with 135, how does time change to go from 6 to 4? 2.
How come I'm so excited? How is it $45?
Because cost is in dollars. $135 minus $90 is $45. 2 hours. So what is the rate of change? If it's 45 over 2, what's the rate of change here? What's 45 divided by 2?
22.5.
It's 45.
It was
22.
Dollars per hour?
Secret team C depends on this box.
I don't know.
Let's open it. Bomb. They're
No.
bombing us.
No.
He knows what it is.
The graph shows the number of computer games sold on day 1, day 4, day 7, and day 9 of a sale. This is telling us how many games are sold on a day. Okay. Describe the rate of change of these. So let's describe, just in words, in generalities, how much are we selling games faster? Where are we selling games, say, the fastest? Where are the games flying out of the store the fastest? Before you back up. Where are the games being sold the fastest?
50.
The one with the biggest slope. So from here to here, we're selling games the fastest. They're being sold quickly. Where are games being sold the least fast?
There.
Where's the smallest? Where the slope is the smallest.
So day 4 and day 9.
Yep. Yeah, so we'll wrap this up on Monday. We'll review on Monday. In your homework, you take a picture of what's on the calendar. Okay. It's on your course calendar. Do as best you can. We'll finish it up on Monday.
Or state. I don't have enough time to write this down.
So this one, I want you to take a look, and then I'll grade it. And then we need to, depending on how you do it, we'll talk about maybe what information from the instructions. So get back on the things you didn't quite get. Starting on the weekend and prepare for them. We'll talk about how they're if I want to see them.
Oh, it's
What are we supposed to do for
Scientist studies section for the temperature. Okay, so here's the function of temperature versus the distance. So
There you go.
right, Lou? So there's that equation. So where are you going? No, stay here. No, don't walk away. Okay, so the temperature. What temperature range did you want to be between? It's set on this. It's set on like it wants to somewhere between this number and that. Perfect.
2095.
20 degrees, 95 degrees. So I want to figure out where this line is when T is 20 or T is 95. And your equation was what? T is equal to.
20 plus 25.
Was it this or was it the opposite?
It's 20 plus 25.
So figure out what D's can you plug in to get T is somewhere between those two. Well, you could make a table. And plug in values of P.
Okay.
So you can say when D is 0, T is 1.
I think it's just a great style. I think there's any problem.
And plug in here. And figure out T's and then find the ones that match up. And then put those points on your graph. Ladies.
I was just gonna ask you, are we gonna have a question where like you have to do scientific notation?
No.
But it,
No scientific notation.
oh, okay, well then screw it.
Okay. Hours. 20.
I'm leaving at 2:30, but she said we're down at 2:20, so we're
How was tornado drill today?
at 2:30. That's what my 4th hour teacher.
I bet you I have an email about that too.
So I could have it.
Now? Yeah.
I got
Let's go. I will. Take the cup from one and throw it in the air. It's you in the air.
I'd have to do it. She has to.
Can I teach today? Give these kids a lesson.
What?
So can I teach today?
You should probably get your econ project going. And what's this about wanting to wear a Hooters girl outfit for your thing? Get Mr. Bass fired.
Hold on. Maddie asked if we could wear these outfits.
Okay,
I did.
you're supposed to say, Maddie, that's a bad idea.
I told Maddie it's a bad idea.
Okay.
She was like, oh well, there.
Okay.
So,
Make sure you don't take part in next year. It'll be bad. All right, folks. I want to go over any questions from the last section, answer any questions from before, and get you rolling because the quiz is not very long, but it could be if you choose not to.
Hey,
Mr. Fisher, I'm so excited for tonight.
I haven't decided. I should. Maybe I'll just collect it for the next quiz. For the Chapter 6 quiz, I'll just collect 5 answers and first episodes. Okay. Here we go. I want to answer any questions from 5.4 so you can get time to work. Okay, 5.4.
Oh.